Hi guys, we're going to begin our study of DC circuits and circuits in general and voltages, capacitors, currents, and resistance. So much fun stuff. So the first thing we're going to talk about is chemical energy. Chemical energy is used in many things that we use today, such as batteries and flashlights, clock radios, TVs, everything. The chemical energy separates charges and it creates a potential difference between. I'll talk about potential difference later, but on a circuit, so here's a picture of a circuit. So this is our picture of our circuit, but how in the world does a battery separate these charges and create, this is a positive terminal by the way, positive, and this is a negative terminal. And my question is, how does this battery separate the positive and the negative terminal? Well, to answer that, this battery or voltage source must do work. And the work per unit charge, so the battery must do work on the charges to create this potential difference, or the difference between a positive and a negative terminal. And voltage equals the work per unit charge. So this is work per unit charge. Sorry, that's not very clear. And this can be also referred to as the EMF force. And they're the same. And then remember that volt is also equal to joules per coulomb, and this is charge and this is work. And work is measured in joules and charge is measured in coulombs. So when this current flows about this circuit, there is a voltage drop across the circuit because the current converts the potential energy into work. So I'll provide you an example. So if this circuit had a voltage of, let's say, 25 volts, well, how can we interpret this 25 volts? Well, this means that the current must drop 25 volts to send the electrons that are flowing across the circuit from a negative to a positive terminal. Alright. Another thing is, and that's pretty much all for voltage. So next thing we're going to talk about is current. What is current? Current, I want to erase all this. What are currents? Well, let's say a current, well, first thing I'm going to jot down is that I, which is a symbol for current, is equal to coulombs per second. So it's pretty much how much charge is passing through a given point of a circuit in an amount of time. And then in a circuit, let's say, this is a picture of a circuit. So here's our positive and our negative terminal. This is what happens. The flow of electrons moves from the positive to the negative. So let's draw a picture of this. That's not a very good picture, but you guys get the point. So this is a flow of electrons. It flows from the positive to the negative. And current, so in this instance, so let's say if the current was 6 amps. Amps is the unit for current. It is equal to 6 amps. So what is amps equal to? Well, according to this equation, amps is equal to coulombs per second. So what if I said that the current here was 6 amps? Well, that means currently 6 coulombs of charge are passing through this point in 1 second. Well, let's say if there was 2 seconds. Well, if there was 2 seconds, you just multiply by 2 seconds to cancel it out, and that means there'll be twice as many twice as many charges passing through. And another thing is, we're going to talk about the direction of the current. Well, we already said the current flows in opposite direction, from the positive terminal to the negative terminal. Well, and that's pretty much all. So let's summarize this lesson. Well, we learned what an EMF and a current was. The current was basically how many coulombs of charge pass through a given point in a given amount of time. Another thing we learned is the EMF for the voltage. The voltage just pretty much summarizes how much work is required to move across the terminals. And like what charges have to have a potential difference drop. And then the next lesson, we're going to talk about resistors and their relationship to currents and voltage drops. So thank you for watching, and please come back for the next video.